or 100, right? It is basically that we have seen how he performed in the previous matches. We have known the history. So we have some reasonable assumptions based on his past track record, right? So, but at the same time, if somebody tells me that, okay, prove it, right? So then basically I don't have anything to prove that. Okay, definitely he's going to make a 60 or a 70 or 80. So the reason why I'm saying all this, basically we are trying to guess here, trying to guess on something, on some event or some outcome, right? But at the same time, it is not like a lottery kind of a thing, right? We have some reasonable assumptions on any event, on any outcome. So based on that, we are trying to predict something. So that is basically what a hypothesis, right? Making a guess at the same time, it's not a wild guess. I'm not simply sitting and saying something, some number. No. Considering some assumptions, considering some reasonable assumptions, I'm going to make a guess, which is always true in nature. Most of the time it is true in the nature, right? So say making a guess based on assumptions without scientific proof. I cannot prove. If you ask me that, okay, can you prove that outcome? Can you prove that output or anything it can be? Can you prove that Virat Kohli is going to make 80%, 80 more than 80 runs? I cannot prove it, but yeah, I can guess it, right? Or explaining the situation based on the reasonable assumptions. That is basically a hypothesis. And how many types of hypothesis we have? A null hypothesis and alternative hypothesis. I can denote null hypothesis as H0 and alternative hypothesis as HA. What is null hypothesis? Null hypothesis, decision always leads to status quo. What is status quo? So whatever we have our imagination, whatever the assumption we have, so always we are going to stick to that decision. If Virat Kohli gets out, at 0 or a 5 or a 10 in 2 or a 3 or 4 matches, right? So in the fifth match, still we are going to assume that, still we are going to guess that he is going to make above 60 runs or above 50 runs only, because we have that perception, right? So my decision will be always same. So that is what this guy is telling. Current status, assumptions doesn't change, because my assumptions are not going to change even though he gets out within 10 runs in the next 3 or 4 matches. The fifth match, still I'm going to stick to my original guess, that is above 50 or a 60 or a 70. So that status will remain same. My assumptions doesn't change. That is basically a null hypothesis. Like if I give one more example, in your academics and all, you have seen some students, they always score in a first test, there is second test and a third test, right? In the first test, say that, let's take only one student example. He has scored 70 marks out of 100, and in the second test he scored 80 marks, and in the third test he scored 75 marks, right? So in the main exam, we can guess that this kind of a students, this type of a student will score around, or I would say greater than 65 marks, because we have seen that track record. So based on that, I'm going to guess this number. I'll say greater than 65 or a greater than 75 marks, right? So that is basically a null hypothesis. guessing something, guessing some events, guessing some outcome, whatever it is, right? So that is basically a null hypothesis. And if I talk about alternative hypothesis, it always opposite to null hypothesis. Decision leads to opposite of null hypothesis. So why we are discussing this hypothesis, null and alternative, right? So if I want to do some kind of a testing for any reason, for anything, right? So we always have a hypothesis. We always do have a null hypothesis. Okay, if this is the situation, my outcome is ABC. If this is the situation, my outcome is going to XYZ. Right? Some assumptions we have in each and every field. Right? So why do we need this alternative hypothesis? We always wanted to prove it wrong. Virat Kohli is going to make a greater than 80 runs, but I want to conduct a hypothesis test. Right? Always I want to conduct a hypothesis test so that I can prove this is wrong. So that is why we conduct a hypothesis testing. So if I'm not able to prove, that is fine. I will stick with this number. If I'm able to prove it wrong, so basically I can say that, okay, this is not the right guess, right? So that is the idea here. So whatever the null hypothesis we have, whatever the assumptions we have on any event, on any outcome, we always try to test it, whether it is statistically significant or not. So with some proof, with some formula that we are going to conduct, right? So yeah, that is about a hypothesis. And what we will do, we will try to understand, we'll try to see some kind of example here, and we can interpret all this data in terms of null hypothesis and alternative hypothesis, when we can reject the null hypothesis, and things like that. All right. Now, before getting into that, we need to understand the statistical tools. Statistical tools, a t-test, ANOVA. We'll talk about ANOVA later, but right now we'll discuss about a t-test. T-test can also be called as a student's t-test, right? Another name. Student t-test and t-test both are same here. All right. Now let's get into the problem here. I have a data set related to marks. So let's visualize those marks. Yes, these are the marks, and basically this is a data set where I have some data like math 1 and math 2, right? And we also have a program 1, 2, 3, 3 programs and some other data as well. Now let's understand this problem statement so that we can interpret in a better way. A teacher wants to teach students for a competitive exams. She collected a sample of students marks from different schools, and based on her past experience, she believes that. We can note, she believes that based on what? Based on her past experience. As I gave Virat Kohli example, based on our past, whatever we have seen, based on our experience, we always believe. Similarly, teacher believes based on her past experience that these type of students will score more than 60 marks in the exams, because she has seen such kind of students in her experience. So she believes that this type of students will score more than 60 marks. Now, she cannot blindly believe on that. So what she wanted to conduct a hypothesis test on the marks. Let's see that whether my assumption, my hypothesis is right or wrong. So basically, what is null hypothesis here? Null hypothesis is H naught the average data, average marks will be always greater than or equal to 60. As you can see here, right? These type of students will score more than 60 marks. That is the null hypothesis she is making. Now she wants to conduct a test. And what is the alternative hypothesis? Yes, it is opposite to null hypothesis, that is less than 60. Mu is basically average. All right. So let's conduct a test here. What I'm going to do for that, I am going to first get the mean of maths 1. Okay, mean of maths 1. So that is 52.645. I have taken this particular column math 1 and I figured out a mean data, and that is 52.645. And we'll talk about this alpha later. And x bar is what? 52.645. This is a x bar or a sample mean, right? So, and mu is what? Is 60 here. And what is this alpha? I will come back to this. All right, when we talk about a p-value. So yeah, mean data and of a particular sample, and this is the average of this marks, average marks. That is a null hypothesis data here. All right. Now in the t-test, we have two types here. One is one sample t-test, and one more is two sample t-test. Right? We'll talk about a two sample t-test. First, we'll implement one sample t-test. So since we are conducting a test for one sample, we will go for a one sample t-test. So how I'm going to use this one sample t-test? All right. So let's look into that. So for one sample t-test, what I'm going to do, I'm going to use this ST. ST is scipy.stats. I hope I have imported that. Otherwise, let me import it. Import scipy.stats ST. All right. So I'm going to import that, and I'm going to use this ST dot. For one sample t-test, formula is very simple, or this method is very simple. How I'm going to write ST, this guy, t-test is what we are trying to conduct, underscore, since we are conducting one sample t-test, I will say one samp, right? ST dot t-test underscore one samp. There I am giving a one sample means only one set of a data, that is a maths 1. So HYP is basically my data set, and there I'm selecting a math 1, this guy, and I'm giving the average data. Mu is basically 60, right? That is what I'm going to give. Very simple. So let me execute. I think I have executed this. Let's execute one more time, and yes. Now, what data we are seeing here? We are seeing two sets of a data. One is a statistic data and another one is a p-value. We are not interested in this guy. We are interested in p-value, right? So what is a p-value here? P-value says 1.33391 blah blah blah, and we have an exponential of -22. How do I write this? We can write, if it is a negative, we can write dot 0.00000 up to 21 times. If it is a 22, 21 times, then we'll continue with this number 13339, whatever it is. That is how I will be able to write this p-value, right? You can also separate that p-value and the statistics just like this. As you can see, I will, since we know that it is going to generate two sets of a data, statistic and a p-value, So I'm going to write separately S comma P, and I use the same formula here, and I mention the math one sample, and my average or the mean data. I execute and I get a S and P, the same data over here. All right. So fine. Now let's not worry about this. Now I got a p-value. So what exactly is p-value? Right? What exactly is that p-value? P-value determines whether we should reject the null hypothesis or we are failed to reject the null hypothesis. Right? So null hypothesis is basically the average score of the students greater than or equal to 60 marks. That is how they are going to score. That is the assumption what teacher has. So that we are going to call it as a null hypothesis, and we are trying to prove it. A teacher is trying to prove it whether this is right or wrong. So for that she conducted a t-test, one sample t-test. She has taken only maths, one score, only one sample. So for that we got the p-value something like this, which is 0.0000001333. So this p-value tells that whether we should reject null hypothesis or we fail to reject, and when we can say we can reject the null hypothesis. When we can say that, okay, this assumption, whatever you have, that is wrong. So that one we are going to compare with alpha. What is my alpha? Let me write it in a clear. Okay. If my p-value is less than alpha, then I am going to reject null hypothesis. What is the alpha value? We have a p-value, which is this guy. What is the alpha? That is where we have this alpha here, 0.05. So this is the industry standards which everyone refers. If my p-value is less than alpha, then you can reject the null hypothesis. It means that whatever assumption you have about students, that is entirely wrong. And I will reject your assumption. I will reject your null hypothesis. So that kind of a information, that kind of a conclusion we can make with the help of this p-value, which we are going to compare with the alpha. Alpha is 0.05. So you may ask that what is 0.05? So if I draw something like this, so we always try to take a 95% confidence interval. It starts from 0 and ends at 1. We always want data between this area. If it is a 0 to 1, I'm going to mark this data as a 95%. That is nothing but 0.95. And the data on the extreme right and this extreme right left are going to take together 0.05. If you sum that, 0.95 and 0.05 will get a 1. So we always look data in this area, from here all over this place. If my p-value is less than 0.05, it means that it is not significant, right? It means that my data is falling somewhere here. If it is less than that, if it is still less than that 0.05, then obviously the data is not falling over here. So that is why we are going to reject the null hypothesis. That is why we consider this 0.05. This is the industry standards which everyone uses whenever they start looking into p-value in order to reject the null hypothesis, and are we going to fail to reject the null hypothesis. That is the importance of this p-value. All right, if p-value is not less than alpha, then we have failed to reject this null hypothesis. Right now, the conclusion of one sample t-test, since we have considered only one sample. So based on one sample t-test, we can say that whatever the assumptions teacher had, whatever the null hypothesis teacher made, which is completely wrong, we are going to reject her decision. We are going to reject her assumption, which is not true. All right, that is one sample t-test. Now let's move on to two sample t-test. Two sample t-test. In two sample t-test, again there are independent sample t-test and paired sample t-test. So this time, what I'm going to do, I'm going to conduct two separate tests for independent and paired sample. This time, let's see that whether her assumption is right, whether her null hypothesis is right or wrong. Because earlier we had used only math 1, but we have also, let's print this, we have also math 2, because she might have considered math 1 and math 2 marks. Based on that, she has some assumption. We always in our college first test, right? Sometimes we may get a less number of marks, but in the next test we may improve our study patterns. We may improve our score. So if you take average data, math 1 and math 2, yes, maybe my score will improve. That is what a teacher has done here. She considered math 1 and math 2 score. Based on that, she has drawn her assumption. Now I want to test that as well. So what I'm going to do, I am going to first conduct an independent sample. Right? So now let's see. So independent sample, basically what I'm going to do, I'm going to first check on a gender, based on the gender. Then we'll come back to paired sample. All right? So independent sample. So here what I'm going to do, male and female, 0 male and 1 is female. What I'm going to do, I'm going to check the value counts of this gender. I have a 0 and 1 value. I want to check how many zeros and how many ones. Let me execute this. Yes, 1 is having a 109. Suppose say 1 is a male, 0 is a female. We have a 91 counts and 109 counts of this number 1. All right. So now what I'm going to do, I am going to subset the data on gender. So if my gender equal to 1, take their math 1 marks and check the head. Yes, we have considered only gender equal to 1. So that is how this data looks like. As you can see, the index is also getting changed here. So now what I'm going to do, I'm going to conduct an independent sample t-test. So for that, a very small change. So we have seen a one sample t-test where we have written st.t-test underscore one sam. I don't need to do so much of change here. I will write everything same, st.t-test underscore. I will just write a ind, that is independent sample. So I'm considering for a gender equal to 1 from this data set where gender equal to 1, and I will take math 1, comma, I will select again gender equal to 0. This is for a male and this is for a female. Conducting independent. one for male, one for female. So for both cases, I'm selecting the math one only. All right. So that is how I will be able to write this independent t-test. Now, if I execute that and I have separated a t and a p, we know that it is going to give two outcomes, but we are interested in a p-value. So if I execute, my p-value is giving me 0.68. If I check that p-value less than alpha, so my alpha is 0.05 and my p-value is 0.68. Is it less than 0.05? No. If it is not less than 0.05, I cannot reject it. So what will happen? What just happened? We failed to reject null hypothesis. You see that how things are changing? When I conduct an independent sample t-test, my p-value is getting higher. Where I used only one sample t-test, my p-value is very less. There we were able to reject the null hypothesis, but here we have failed to reject the null hypothesis. Failed to reject null hypothesis, it means whatever teacher assumed, that is right. We failed to prove. We failed to prove the null hypothesis. Right? So let me correct that. We failed to reject the null hypothesis. Right? I cannot say I will accept the null hypothesis. I simply say that we failed to reject because we have conducted this t-test to reject the null hypothesis. When I fail, when my statistical analysis fails, I can say that we failed to reject the null hypothesis because my p-value is not less than alpha. It is greater than alpha. Right? So that is how I will be able to conduct a independent sample t-test. All right. So then one more sample, that is a paired sample t-test. Here what I'm going to do, I'm going to take when I say pair, obviously two samples, math 1 comma math 2. Right? So I'm going to take two samples and I'm going to write here st.t-test underscore, instead of independent, I'm going to write REL, relational, REL, this guy. When I say relational, yes, obviously I have to give two samples, paired one, math 1 and math 2. So this is also going to give a T and a P. We are interested in the P value. That is what is required to check the assumption. That is what is required, whether based on the alpha value and based on the P value, we are going to compare. That is required to check whether we can reject the null hypothesis or not. So what I'm going to do, I am going to execute this and I will print this P value, and this is giving me 0.17. Is it less than 0.05, which is alpha? It is no. It is not less than 0.05. It means that again we failed to reject null hypothesis. What was null hypothesis? Null hypothesis was greater than or equal to 60 marks. We failed to reject. It means that whatever the experience teacher had, based on her experience, she assumed that this kind of students are going to get more than 60 marks. That assumption is absolutely right, because we failed to prove that alternate hypothesis is correct. We failed to reject this null hypothesis. Right? Because my p-value is not less than alpha. So that is what the t-test, right? One sample t-test, two sample t-test. In two sample t-test, we have independent and pair, right? So that is how the hypothesis testing will be done. So we have one more hypothesis testing, that is nothing but ANOVA, analysis of variance. Analysis of variance, or in simple, we can call it as ANOVA. All right. So let's understand something before getting into this analysis of variance. In the earlier videos, we have understood what is population and sample, right? So when we are not able to describe this entire population, what we used to do, we used to take some sample and we are going to do some kind of analysis on this sample. Then we used to infer the results of the sample to the entire population. That is a part of inferential statistics, right? So that is how we used to interpret the population. But I have a problem here, right? Say that population is all elements in groups, whereas sample means a randomly selected subset of the population, right? So sometimes it is not always feasible or possible to collect a population data, right? So what we do, we perform analysis using some samples, right? So now let's say that for instance, there are college students and there are so many students, and those students, we call it as a population, right? And what we do, we have so many students and we'll take some sample, suppose say 1,000 students, right? So say this is a population is Indian students, all Indian students. We have so many students and I want to do some analysis. For that reason, I have collected 1,000 samples from this population and this is the sample. So when I analyze this sample and if I try to infer to this entire population, sometimes it is not reliable to directly apply the sample analysis results to the entire population, right? So what we need to do? So we need to have a systematic ways to justify the sample results, whatever the results we are going to get. We have systematic ways to justify these results to the entire population, right? So this is the reason why we need a statistical test, right? So we have seen in the earlier video t-tests. So similarly in this ANOVA, we are going to discuss something different. So coming back to this example, so we evaluate how likely this sample results are, whatever the analysis we make, how likely the sample results are true representation of the population. So is it reliable or not? So for that, we need to conduct some tests, right? So we always set some null hypothesis and alternative hypothesis, things like that. So now, when there are two groups, right? When there are two groups in the t-test, we have seen math 1 and math 2, right? When there are two groups, yes, we always prefer to use a t-test, right? But when we have more than two groups, greater than two groups, then t-test will not be feasible. Suppose say there are three groups, A, B, C. In that case, I have to conduct a t-test on A, B, and C, right? So this becomes harder to manage. So thus, for that reason, what we are going to do, we are going to use ANOVA, right? So that's where ANOVA will comes into a picture. What this ANOVA does, let me take this guy out. What is this ANOVA first of all? ANOVA is used to compare differences of means among more than two groups. Suppose I have A, B, C. It will compare the differences among these three groups. It does this by looking at a variation in the data. So I have a data here, I have a data here, I have a data here. By looking at the variation in the data, where that variation is found, that's why we call it as an analysis of variance. So specifically talking, so ANOVA compares the amount of variation between groups, amount of variation between groups A to B, A to C, and B to C between the groups. One group, two group, three groups, right? The variation between the groups with the amount of variation within the groups. When I say within the groups, this is the within the groups, within the groups, within the groups. Between the group means A versus B, A versus C, B versus C. Right? So we take all those data, then we'll find the F value. Sample means of between groups divided by sample means of within groups, within A, within B, within C. Right? So then we'll get a F value. What is this F value? So F is a ratio. It's a ratio, is a measure of the comparison between variation between groups and variation within groups, as you can see here. All right. So what happens there? If F is higher, if F ratio is higher, then it indicates that variation between groups is larger than the individual variation of groups. Right? In such cases, it is more likely that the mean of groups are different. Right? Mean of groups are different. So group of mean of A, mu of A, mu of B, mu of C are different. Right? In case F value is less or low values, right? So in that case, the individual variation of groups are larger than the variation between groups, right? So with that, we can conclude that the elements in a group are highly different rather than the entire group. All right. So that is basically what we can interpret with the help of F value, and we'll see with some example and understand. All right. So let's take one example here. Example. Let me remove this. Just interpret. We are not going to execute this example, but we can interpret this. So we are trying to predict the product sales based on the promotion, where low, middle, and high value promotions are categorical in nature. Like low is a radio, newspaper, middle is basically billboards, public places, high level TV ads. So it means that if I want to promote my product, I can advertise in a radio and a newspaper where I need a very less amount to promote, because in radio I don't need to show anything. It just I just need to speak. Okay, this is the brand XYZ. It is very good. You can take it. I can just give one ad in the newspaper, just print out, send it to newspaper agency, then they will just print it. So there we don't need much of a amount, much of a money to promote my product. So we can categorize it as a low medium, or I would say low investment. So in the middle, so billboards in public places, I have to put the hoardings in the signal, or maybe in the airport, or maybe somewhere where there is a traffic. we will set a big board, right? So where I will just mention my product, something, some product. Maybe if it's a car, this, right? I will just need to publish this car. So it takes some extra amount. So, but higher than this, radio and newspaper, I'm going to categorize it as a medium investment. And a high level is basically TV ads, where I need to hire a celebrity. I need to select the location. I need to pay money to the cameraman, and some script also we need. And we need to pay money to the celebrities. And on top of that, I have to pay to the TV channels, where we have to pay on for each and every second, right? If it is a 10 seconds of ad, we have to pay some lakhs. If it is greater than 10 seconds, again our investment is going to increase. So there you have to pay so much of amount to different people. So then I'm going to set this as a high level investment. So based on low, middle and high level categories, I'm going to predict sales. That is, sales is again continuous data, right? With the help of categorical data, I'm going to predict the continuous data. So there we can use the ANOVA. Just an example, right? So now what we will do, we will use one example and see how ANOVA works. All right, let's get back to action. All right, so let me execute this so that we can interpret in a better way. So here what I have three groups, A, B, C, and these are student 1, student 2, student 3 marks in different groups, A, B, C, right? So now how to start, how ANOVA works behind the scene. In terms of a formula, in terms of an equation, it's very simple, but how it is going to work behind the scene, let's understand. So before that, let's construct a hypothesis here. What is the hypothesis, right? So that is why we, to understand, to conduct a hypothesis test, we use a ANOVA. But what is the hypothesis? Hypothesis is, the null hypothesis for ANOVA says that average of dependent variable are same for all given groups. Alternative hypothesis says mean of dependent variable are not same for the given groups, right? So null hypothesis are basically all are same. Average of A, average of B, average of C, all are same. That is what null hypothesis. The alternative hypothesis obviously not equal. Now we want to conduct a test, right? Now let's see. So the first step is basically finding the mean, because ultimately we have to reach to the level where I can implement this formula. In this formula, what we need? We need sample means between groups, sample means of within groups. I need to find this. How will I be able to find? So I have to start finding the mean first. Mean of A, mean of B, school B, let's call it as a school, A, B, C, mean of school C. All right, I'm going to get the mean of each school. Then I have got this data for school A, B, and C, right? That is the first step. And in the second step, I am going to calculate the grand mean. Grand mean is for this entire data, A, B, C, and all the observations. For that, I already have a mean of each and every school. So I will just add all of them. And how many schools we have? 3. I'll just divide it by 3 and I will get the grand mean of all the schools. It is 71.44, which is a grand mean. All right. Now I have to find the sum of squared total within and between. So variations between, within and total. So what I'm going to do, if I want to find the sum of squared about a grand mean or the total, so what I'm going to do, I am going to first take the grand mean, which is 71.44, minus, for the school A, I will take all the observations. Mean minus first observation of school A and square it because it's the sum of squared, plus grand mean minus second observation of school A, square it, plus grand mean minus third observation of school A. 82, 83 and 97 all are from school A. 82, 83 and 97. Right? So that is what I got. I'm going to square them, plus again for the school B, grand mean minus school B first observation, school B second observation and third observation, plus grand mean minus school C first observation, school C second observation, school C third observation. Right? So all this data over here. All right. So once I do that, I will be able to get a 2630.2. That is basically sum of squared deviation, sum of squared total. All right. Sum of squared total. Then I want to do some kind of operation for the sum of squared within. Within means within A school, within B school, within C school. Right? Within. All right. Let's draw this way. School A, school B, and school C. I have a data here. So this SS total is for this entire. Now I want to find the SS within, between A, within A, within B, and within C. For that, we have figured out a mean of A, which is 87.3, minus first observation, which is this guy, square, plus again mean, minus the second observation, square, plus mean, minus third observation, square. Similarly, this is the school B mean, school C mean, and respective data points. Here 83, here 78 and 68. Same thing for the C. So then I will get a SS within, which is 506. Sum of squared within. Right? We got the grand, we got the within. Now we need to find the between. A versus B, B versus C, and C versus A. Right? So for that, we are going to use a grand mean. We know grand mean minus group A mean square. Multiply by 3. Why it is multiplied by 3? Because 3 is the number of items or students in the group A and group B and group C. We have 3. That is why I am going to multiply with this 3. In group A, in group B and group C, we have 3 observations. So I am going to multiply all those with a 3 only. So grand mean we figured out, group A mean we figured out, group B and group C mean. I am just going to find the difference and square it, and I will be able to get this data. All right, you can do it. You will be able to get only this data only. Now I need to find the degrees of freedom. So in order to reach the main formula, I have to do all these things. All right. So what is degrees of freedom? So in order to understand the degrees of freedom, let's do a small a task here. So say that I want you to write some numbers in these three places. So that will sum up to 100. You can choose any number in the first instance. I can choose 10, I can choose 20, I can choose 30, 40, 50, whatever number I want I can choose. Let's say that I will choose a 40. And here I can choose any number here again, right? So I can choose 50 here, I can choose 59, I can choose 10, I can choose 1, any number I can choose. I have a freedom. Here also I had a freedom. Here also I have a freedom. Let's suppose say I can choose 50 here, right? I have a freedom here. Now here I don't have a freedom, right? I have to choose only 10 in order to make up to this 100. In this case, I do not have a freedom. So how much of freedom I had? So suppose say three numbers we were asked to give, and minus for 1 I did not have a freedom. So that is minus 1. Out of 3 I have 2 degrees of freedom. I had freedom for this guy and this guy, but not this guy. This is basically degrees of freedom. 2 is the degrees of freedom if I have 3 observations, right? So that I need to find. So first I'm finding the degrees of freedom for the total. So how many observations I had? Total 9 observations, 9 elements. Out of that, I'm deducting minus 1. So my degrees of freedom for a total is 8. And between means A, B, and C, how many groups? 3 and minus 1. And I have degrees of freedom 2. And within basically how many observations? We had 3 observations, 3 and 3, total 9. And if I take out 1 here and 1 here and 1 here, that's minus 3. So degrees of freedom basically 6. Right? So that is basically the concept behind degrees of freedom. Now what I'm going to do, I'm going to come down. Since we have figured out SS between, right, divided by degrees of freedom of between, degrees of freedom between. So we have this data and we have this data, and mean squared between groups is what I'm going to get here, this guy. Similarly, within, SS within we have divided by degrees of freedom within also we have, where I'm going to get mean squared within groups. We got a mean squared between groups, mean squared within groups. If I execute that, okay, I did not execute this. Give me a second. I have to execute this, and this. So what we were looking, go back all the way here. We are looking for means of between groups and means of within groups. What we got here? Between groups and within groups. If I execute that, I will get 12.5940. This is the F value. But where is the P value? P value you will be able to get in the F table. What is the F table? Right? So in our academics or in the +2, so we have seen this log tables and things like that in the last page of the textbook. So we used to refer that table and find some values, right? So similarly in the F table, I have to refer this guy, 12.5940, and there you will be able to get a P value, right? When I use this F value, I have to give a degrees of freedom between 2 and within 6. We have figured out that. So if I use all this data, my P value is going to be this bond number, that is .007. All right. So yes, we know what we can do with the p-value. If it is some kind of a use case, we could have interpreted in a better way. But what is the null hypothesis here? Null hypothesis is all the means, right? All the means are equal. Now p-value is 0.007. So when I say p-value, again I have to check p-value. If p-value is less than alpha, then I'm going to reject null hypothesis. What is the p-value? P-value is 0.007. What is the alpha level? Alpha level is 0.05. That is the industry standard. Is it less than alpha? Yes, it is less than alpha. Then I can say that all the means are not equal. We rejected the null hypothesis. Right? So that is what we have concluded here. All right. So this is how it is going to work behind the scene. Now, how do I implement in the statistics? Let's see that as well. So here I'll quickly go through this. As you can see, this hypothesis test data set, math 1, math 2, and we have a program here, 1, 2, 3 programs. So 3 groups. So what I'm going to do, I'm going to re-execute, and here I have used stat models.formula.api, which I'm going to import. There I'm using the ordinary least square method. OLS is ordinary least square method. There I'm checking math 1 versus this program. So programs are basically 3 programs are there, 1, 2, 3 programs. So which means that there are more than 2 groups, right? So more than 3 categories. So I'm going to use that. That is what we have understood. Categorical data and finding the continuous data. Math 1 is the continuous data, program is the categorical variable. So I'm going to use sm.ols method, where I'm going to give math 1, this is the tilde symbol, and I'm going to give the categories. Then I'm going to give my entire data set. And I will say dot fit. So dot fit is going to be like looking into each and every program and analyzing the data, finding the patterns and things like that. So that is what dot fit method does. I'm going to store all the result in this mod. You can give any name. So then I'm going to import stats models.api. These are all the stats models. Then I'm going to use this K. K is what short name which I have given for this guy. K dot stats dot ANOVA underscore LM. Right? This is the method that we have in the stats models. It is not something I have derived. This is what we can use in order to use the ANOVA. ANOVA underscore LM. Now I'm going to give this entire data, mod, MOD. When I give that data, so I'm going to print this AOV table, which is already instantiated here. Let me execute. It's going to take a little time, yes. So now you can interpret everything. Only I can use only this models. Only how many lines of code? 1, 2, 3, 4. In 4 lines of a code, I am able to do each and everything here, like all this mean, grand mean, total, within, degrees of freedom. Everything will be done behind the scene when I use these stats models. And here you can see program and the sum of squared, mean squared, F value, and this is the P value. Right? So program, as you can see, between, right? Residual is within. This is a within. And sum of squared is nothing but a sum of mean minus x square that we have calculated. And program, as you can see, mean squared, that also we got in this case, SS between divided by df between, right? We have got so much of data here. The residual, so f value, PR is a p value, everything will be able to see here, right? So we are ultimately interested in this guy. P value is 0.03. 0.03 is less than 0.03 is less than 0.05. It means that whatever the null hypothesis we have, we are going to reject that. Reject null hypothesis. All right. So that is what is basically the conclusion. Null hypothesis is in each program, all the marks are same. The mean marks are same. Right? In program 1, mean marks of math 1, math 2 are same. In program 2, mean data is same. In program 3, mean marks are same. That is the null hypothesis. With the help of ANOVA, I am going to conduct a test with the help of ANOVA stats models, and I will be able to find this p-value, and based on the p-value I am going to compare with the alpha, right? And now I will be able to make a decision that is nothing but reject the null hypothesis, which means that not all the programs means are equal. They are different. All right. So that is all about the ANOVA. Hope you have got this on what is ANOVA and when we should use ANOVA. Right. So yes, that's all in this video. Thank you for watching this video. See you in the next.